So hello my dear students, today in this class we are going to solve exercise number 2.1. Okay, in last class you already know about the Euclid geometry, their definitions and axioms and postulates. Okay, so on the basis of that concept now I have to solve some examples. Okay, so first question is, which of the following, these are the following statements. Okay, the following statements are true and which are false. Okay, if they true, give reason. If they false, give reason for your own answer. Okay, so first we have to see the first statement is only one line can pass through a single point. Okay, only one line can pass through a single point. Now see here, it is a one point. Okay, so in that point, how many lines can be passed through? See here. In last class, I will already explain this concept. Okay, these are the lines. Okay, and this is point called as a O point. Okay, it is a single point. And these all lines are passing through that common single point, which means this statement are true or false? Yes, absolutely, this statement is false. Okay, so your answer is false. And your reason means the infinity number. Okay, the infinite number of lines can be passed through a single point. Is it right? It is one single point and these all lines are passing through this common single point, which means this statement is false. Is it right? So see here, is it clear? First statement is false. Why false? Because the infinity number of lines can be passed through a single point. Next here, next statement, there are an infinite number of lines. Infinite number of lines means so many number of lines which pass through two distinct points. Okay. So see here, this is point A and this is point B. Okay, these are the two distinct points. Okay, and the one line is passed through these distinct points. Okay, this is one line is passed through these two distinct points. Now, what they say the second statement? There are an infinite number of lines, which means so many number of lines can be passed through a distinct point. Okay, so therefore the two distinct points, only one line can be passed. Only one line can be passed through any two distinct points. So this statement is false. Is it right? So this statement is false. Your reason and only one line can pass through. Okay, only one line can pass through two distinct point. Is it right? See here. Only one line can pass through a distinct point. Is it right? So now we move towards the next statement. Okay, the statement number 3. See here, this is third statement. A terminated line can be produced indefinitely on both sides. Okay, so take one terminated line A, B. Okay, this is one terminated line, or you can call as a line segment. Okay, this is one terminated line, and it can be extended or it can be produced. Okay, or it can be extended infinitely or any length. Okay, here also. Okay, so see here statement: a terminated line can be produced indefinitely on both sides. Okay, this statement is true. Why true? Because this terminated line can be extended on both sides. On both sides indefinitely. Is it right? So this statement is true. And give reason. What is the reason here? The terminated line can be extended on both sides indefinitely. Right? So this terminated line can be extended their length on both sides indefinitely. Okay, so is it clear? Next statement is: if two circles are equal, then their radii are equal. First you should have to know if two circles are equal. When the two circles are equal, their center and their circumference will be equal. Okay, their center and their circumference will be equal. At that time, we can call as these two circles are equals to each other. So take one example here. This is one circle. This is one circle, and their radius is 2 centimeter and their radius is 2 centimeter. Okay. Now here this is the circle A and this is the circle B. Their point will be same, and this circle circumference is also same. So now we can call as these two circles are equal. Okay, and obviously the radii also equal. See here, the radius is 2, radius is 2. At that time, their circumference also equals to each other, and the points will be same. Okay, so this statement is true. Okay, we can say this statement is true. Why true? Because if two circles are equal, if two circles are equal, their center and their circle and circumference are equal to each other. Okay, are equal to each other. Their circumference is equal to each other. Obviously, their radii will be equal. Is it right? So their radii will be obviously equal to each other. So that's why if the two circles are equal, then their radii are equal to each other. Is it right? We conclude that this statement is true. Okay. So now move towards the next statement. Okay, statement number 5. Now we have to discuss about the statement number 5. See here, this is fifth statement in figure. Okay, this is the figure. AB is equal to PQ. AB is equal to PQ and PQ is equal to XY. Then the AB is equal equal to xy. Now we have to prove the AB is equal to xy. Okay, so see here, according to Euclid's first axiom, okay, what is Euclid's first axiom? See here, the Euclid's first axiom. Euclid's first axiom says that the two equal things, or which are the equal things, are equals to the same thing. Okay, the equal things which are same to the equal things are equals to each other. Is it right? So see here, the AB is equal to PQ. The next, PQ is equal to XY. Is it right? So now the PQ is equal to AB and XY is equal to PQ. So therefore we can write as AB is equals to XY, because AB is equal to PQ, then PQ is equal to XY. Okay, the absolute AB, obviously AB is equal to XY according to Euclid's first axiom. Then what is the first axiom of Euclid's? Which are the things are equals to the same thing are equals to one another. Okay, so reason we have to write here. Okay, which are the equal things are same to the equal things, then there are equals to each other. Okay, you understood? This statement is now, we can say this statement is true. Is it right? So now we shall start here. In the next class we have to discuss about the question number 2. Okay, thank you.